3 faint stars hang in the autumn dark, a slender triangle small enough to hide behind 2 of your fingers held at arm's length. Beneath them, where the eye finds only a velvet absence, a wheel of light has been turning for longer than there have been eyes to see it. You cannot quite catch it, and then, when you stop trying, it surfaces, a smudge of grey gold haze, oval and soft-edged, resting against the blackness like breath fading from cold glass. It does not blink. It does not move. It has been pouring its light toward this exact moment for nearly 3 million years, and tonight a little of it arrives, landing on the back of an eye that belongs to a creature its makers will never know. That haze has a name given by people who lived and died long before its true nature was guessed. They called the little triangle above it Triangulum, and the soft glow beneath became the Triangulum Galaxy, an entire island of stars, 40 billion suns wound into a graceful spiral, the 3rd great city of light in the small cluster of galaxies our own world calls home. It is far enough away that its glow is among the most distant things a human eye can find unaided, and near enough, in the vast arithmetic of the cosmos, to count as a neighbour. Tonight you're going to drift slowly across it, from its outer haze to its brightest nurseries to the slow gravitational current that binds it to galaxies even larger than itself. There is nothing here you need to hold. You do not have to remember the numbers or the names or the order in which they come. Let the mind grow loose and unhurried, the way water loosens when a fire beneath it goes out. The facts will pass through you like light through a window. Some will stay, most will simply move on, and that is exactly as it should be. You're not studying. You're resting beside something very old and very calm, letting its stillness become your own. What stays, stays. What goes was never yours to keep. Your only task tonight is to lie still and let the wheel turn while you sink. So let the gaze settle on that smear of light and let it grow. What looks like a single grey cloud is in truth a flattened disk of suns seen almost from above, tilted just enough that its spiral shows. 40 billion stars wheel there in slow procession, and the whole of that fire reaches your eye as one soft glow, because the distance has pressed every separate sun into a single wash of brightness. The light you're receiving left that galaxy when the world was warmer and stranger, when no city stood anywhere on Earth, when your own kind had not yet learned to speak. It crossed an emptiness so wide that the journey is measured not in miles but in millions of years, and it ends gently here, on the dark side of a sleeping planet, in the back of a quiet eye. Nothing was hurried in its making, and nothing about it asks to be hurried now. The Triangulum Galaxy belongs to a small family that astronomers call the Local Group, a loose gathering of more than 50 galaxies bound together by gravity across millions of light-years of dark. Most of that family is faint and dwarfish, scattered like embers around 2 great fires. The Milky Way is one of those fires. The Andromeda Galaxy is the other, larger still, and Triangulum is the 3rd in size, smaller than the 2 giants, yet far grander than the dim companions that drift around them. Imagine 3 lit windows in an enormous unlit house and a scatter of candle flames between. You live inside one of those windows. The one you're watching tonight is the 3rd. Those 3 great windows hold nearly all the brightness of the Local Group between them. The Milky Way, Andromeda and Triangulum together account for the overwhelming share of all the stars in the family. The dozens of dwarf galaxies scattered around them, for all their number, add up to only a thin scattering of additional light. So when you look toward Triangulum, you're looking at one of the 3 places where the matter of this whole corner of the universe has truly gathered, one of the 3 deep wells into which gravity has drawn the local stars. The rest is mostly empty space and faint embers, and these 3 quiet fires. It is the closest large spiral galaxy to our own after Andromeda, the 2nd nearest of the great pinwheels, near enough that its light, ancient as it is still among the youngest galactic light to reach us from beyond our own doorstep. Only Andromeda lies closer among the major spirals. Everything else of comparable grandeur is far more distant, its light far older still. There is a particular intimacy in that nearness, in knowing that of all the great spiral galaxies strewn through the endless dark, this modest one is almost our nearest neighbour of its kind, resting just across the way. The whole of it, counting every star and all the gas and the great unseen weight of dark matter wrapped around it, gathers to a mass of some tens of billions of times the weight of the Sun, and yet that entire immensity is held in such perfect balance that nothing about it strains or hurries. The galaxy carries its enormous weight effortlessly, the way deep water carries whatever floats upon it, every part poised against every other in a slow, sustained equilibrium that has held for billions of years and will hold for billions more. Vast mass, and yet no heaviness anywhere in it, only balance and turning and time. It is a spiral, and a particularly elegant one. From your vantage, its arms unwind in loose, open curves, studded with the blue-white sparkle of young stars and threaded with darker lanes of dust. There is no tight, blazing knot at its heart, no fierce central glare. The light simply gathers toward the middle and thins toward the edges, like fog deepening over the centre of a still lake. Many galaxies wear a bright bulge at their core the way a flower wears a heavy head. This one does not. Its beauty is the beauty of something evenly spread, soft all the way through, with no single point demanding the eye. Its light has travelled, by the most careful reckoning, somewhere between 2 and 3 million years to reach you, most measurements settling near 2.75 million light years. That number is almost too large to feel, so set it down beside something smaller. The light that left your bedside lamp tonight crossed the room in less time than a heartbeat. The light from the moon reaches you in a little over a second. Sunlight takes 8 minutes, the nearest star beyond the Sun 4 years, and this faint oval glow has been falling toward you for the better part of 3 million years, older than the oldest human story, older than the human face. You are, in the simplest way, looking into deep time. To find it, an observer waits for a night with no moon, far from the orange wash of any town, and lets the eyes adjust until the faintest things begin to appear. Then, low beneath that little triangle of stars, the haze emerges, never sharp, never sudden, more felt than seen, surfacing at the edge of vision and vanishing if stared at directly. It is one of the most distant objects a person can see with no telescope at all, no lens, no mirror, only the dark adapted eye. Among everything the unaided eye can reach across the whole of the sky, almost nothing lies farther than this soft grey smudge. Its photons fall directly onto the retina after a journey of millions of years, and for that one instant something in the body is touching something almost unimaginably far away. How large it hangs in the sky surprises nearly everyone who learns it. The full moon, that bright disk that seems to fill the night, would fit across the face of this galaxy more than twice over. Triangulum spreads wider than the moon in the heavens. It is only its faintness, not its size, that keeps it hidden. The light is spread so thinly across so broad a patch of darkness that the whole great glow sinks beneath the threshold of easy seeing. A vast thing, dimmed not by smallness, but by distance, lying quietly over a stretch of sky larger than your thumbnail held to the stars. Stretch a thread of light from one edge of its disk to the other, and that thread would run some 60,000 light-years long. A beam of light, the fastest thing the universe allows, crossing at its full unbroken speed, would need 60,000 years simply to travel from rim to rim, and the same beam crosses the entire width of your room in the blink before you notice it has gone. That is the breadth of the place you're watching. A disk so wide that light grows old in the crossing, turning gently in the dark while a single planet, somewhere along the edge of another galaxy, slips towards sleep. Compared to our own Milky Way, this third great city is the more modest of the two. Where the Milky Way holds hundreds of billions of stars, Triangulum holds perhaps 40 billion, a tenth or less of its larger cousin's count, spread across a disk roughly 70 parts in 100 as wide. It is not the grandest galaxy in the family, and it has never tried to be. It is the smaller, softer spiral, content in the company of giants, turning at its own rate with its own loose and lovely arms. There is a quiet dignity in being the gentler one, in shining steadily without the need to outshine. To look at it is, in a way, to glimpse our own home from the outside. We can never see the Milky Way whole, for we live deep inside it, embedded in its disk, able to perceive only the band of its light wrapped around our sky, never its full spiral shape laid out before us. But in Triangulum, a nearby spiral seen almost face-on, we're offered something close to a portrait of what our own galaxy might look like from afar. The open arms, the rose nurseries, the gathered glow at the centre. The distant wheel becomes a kind of mirror held up across 3 million light-years, showing us, in another galaxy's face, a hint of the one we will never step outside to see. Its arms hold a secret that sets it apart from many spirals. They are loosely wound, opened wide rather than coiled tight. Astronomers sort spiral galaxies by how snugly their arms embrace the core, and Triangulum sits among the loosest of them, its limbs flung outward in broad, generous sweeps. Picture cream stirred once into dark coffee and then left alone. The slow opening curls, the soft folding edges, never quite closing into a knot. That is the shape of it, an unhurried pinwheel caught mid-turn, its spiral so open you can almost trace each separate arm out into the dark. And nearly all of that beauty is turned toward you. The disk lies tilted just over halfway from edge-on to face-on, so that from Earth you look down upon its swirl from above rather than along its rim. This is why it shows its spiral so willingly, why its arms and dust lanes and bright knots arrange themselves into a wheel rather than a thin streak of light. Of all the great spirals, few present their faces so openly to us. It turns toward the small blue world that watches it as if it had nothing to hide, offering the whole pattern of its making to anyone patient enough to look. The light gathers thickest at the centre and thins toward the edges with no hard line anywhere, no rim, no border. A galaxy has no skin. It simply grows fainter and fainter outward until the suns become too few and too far to register, fading into the dark by degrees the way a held note fades into silence. So when you look at that oval haze, you are not seeing an object with edges. You're seeing the densest part of a glow that reaches much farther than the eye can follow, dissolving so slowly into the void that no one can say precisely where the galaxy ends and the emptiness begins. The whole of it turns. Not as a solid wheel turns, all of a piece, but as a great slow whirlpool turns, the inner stars circling faster, the outer stars trailing behind across spans of time the mind can barely hold. A single star out near the edge of that disk may take more than 200 million years to complete one circuit of its galaxy. One long orbit, one galactic year. The last time the stars now at Triangulum's rim stood where they stand tonight, the Earth they had never heard of was warm and green and walked by creatures that have since turned entirely to stone. Everything there is moving, and yet from this distance nothing seems to move at all. The whole vast turning holds perfectly still in the eye, the way the hour hand of a clock holds still while you watch it. Hold that stillness for a moment, the immense and silent turning of 40 billion suns, and let it settle low in the chest, where the breath slows of its own accord. Within that turning disk, certain regions blaze brighter than the rest, enormous clouds of gas where new stars are being kindled, glowing pink and rose in the long exposed eye of a telescope. These are the galaxy's nurseries, the places where raw hydrogen is gathering, collapsing and igniting into fresh suns. Triangulum is unusually rich in them. For its size, it births stars at a brisk and steady rate, and its arms are freckled all over with these warm rose-coloured knots of creation, each one a place where the universe is right now, making more of itself out of nearly nothing. The greatest of those nurseries has a name and a presence all its own. It is called NGC 604, and it is among the largest stellar birthplaces known anywhere in the nearby universe. A single glowing cavern of gas spanning roughly 1,500 light-years, so vast that it would take light 15 centuries merely to cross it. Inside the great nebula that human eyes know best, the Orion Nebula, 4 hot young stars do the work of lighting the gas. Inside this one, more than 200 do. It is nearly 100 times the size of Orion's familiar glow, a furnace of creation so large that if it stood where Orion stands in our own sky, it would blaze brighter than any planet and cast faint shadows on the ground at night. A cathedral of glowing gas 1,500 light-years wide, its walls sculpted by the winds of 200 newborn suns. The radiation pouring off those young stars pushes the surrounding hydrogen back into great curtains and bubbles and arching ridges, carving hollows in the cloud the way a slow tide carves a sea cave. The light it gives off is the deep rose of glowing hydrogen, the exact colour the gas releases as it cools from the fire of new starlight. A single cloud, far larger than anything of its kind near home, quietly assembling the next generation of stars across a span of space it would take you 1,500 years to fly through at the speed of light itself. Those rose-coloured regions get their glow from the youngest, hottest, most massive stars buried inside them. Blue-white giants that burn furiously and die young. Their fierce ultraviolet light strikes the surrounding hydrogen and makes it shine, the way an unseen lamp behind frosted glass fills the whole pane with light. So when you see those pink clouds threaded through the spiral arms, you are seeing gas lit from within by stars too distant to resolve. The hidden newborns announcing themselves only through the coloured glow they pour into the dark around them. The brightest fires here are invisible. You know them by the warmth they cast. The dust between the stars writes its own dark calligraphy across the disk. Threaded through the glowing arms run lanes of cooler, darker material. Fine grains of carbon and silicate, the soot and sand of the cosmos, gathered into long, curving ribbons that block the light behind them. These are not empty gaps. They are the richest places of all, the cold reservoirs from which new stars and new worlds will one day condense. Every dark lane you trace across that spiral is a future nursery in waiting, a shadow that is really a promise, the raw stuff of suns held in reserve against the slow centuries to come. Toward the heart of the galaxy, where you might expect a galaxy to be most fierce, Triangulum is instead remarkably mild. It has no great central bulge of densely packed old stars, none of the swollen golden core that crowns so many spirals. Its disk runs almost flat and even all the way in, a wheel without a hub, a spiral that is nearly all arms. Astronomers call such a galaxy a pure disk spiral, and they are rarer and stranger than the bulging kind. It is as though the galaxy never gathered itself into a heavy centre, never built the dense old crowd of stars that other spirals carry, and chose instead to remain open and even, light all the way through. Stranger still, where most large galaxies hide a vast black hole at their core, a sink of gravity weighing millions of times as much as the Sun, Triangulum appears to hold no such monster at all. The most careful searches have found, at its very centre, no sign of a giant. Whatever sits in the middle of this galaxy, if anything does, can weigh no more than a few thousand suns at the very most, a featherweight by the standards of galactic hearts. Among great spirals it is a quiet exception. A city with no dark furnace burning at its centre, turning peacefully around an emptiness where its larger cousins keep a swallowing dark. There is something restful in that absence. The Milky Way and Andromeda each spin around a black hole millions of times the mass of the Sun, ancient and immense. Triangulum simply does not, or holds, at most, something so small it has escaped every search. It is a galaxy that grew up gentle, without that crushing weight at its core, and it has turned for billions of years without it, proof that a great structure can hold itself together softly, bound not by a single dominating centre, but by the patient pull of all its parts at once. That same gathered pull reaches far beyond the glowing disk you can see. Wrapped around the visible spiral, invisible and enormous, lies a vast halo of dark matter, a kind of mass that gives off no light at all, betraying itself only by the gravity it lends. It is this unseen halo that holds the outer stars in their orbits, keeping the wheel from flying apart as it turns. The light you can see is only the bright thread at the centre of something far larger and entirely dark, a luminous fish caught in an invisible net. Most of what the galaxy is you will never see, and it asks nothing of your seeing in order to go on holding itself together. Out at the edges, that great wheel does something subtle and beautiful. It bends. Beyond a certain radius, the disk no longer lies perfectly flat, but curves gently up on one side and down on the other, warped like the soft brim of a hat left out in the rain. Such warps are written into the outskirts of many spirals, the signatures of old gravitational tides, of past encounters with passing neighbours. In Triangulum, the warp is clear and graceful, the disk's far reaches lifted slightly out of true, a record in the shape of the galaxy itself of forces felt long ago and never quite forgotten. Feel how the body, too, settles unevenly into the mattress, one shoulder heavier, one hip sinking first, and let that gentle warping be enough. There is no need to lie perfectly straight. The light of those outer regions is bluer than the light at the core, and that colour tells a story. Blue light comes from young, hot stars, and young stars gather where there is fresh gas to make them. So the blue-tinged arms and edges of the galaxy are its most fertile ground. The place is still actively giving birth, while the slightly warmer, yellower glow nearer the centre comes from older, calmer suns that finished their making long ago. Colour, in a galaxy, is a kind of clock. You're reading the age of starlight simply by its hue, the blue of the new and the gold of the old laid out together across one slowly turning disk. For all its 40 billion stars, Triangulum is a place of profound emptiness. The stars within it are separated by distances so vast that if you stood on a world circling one of them, the next nearest sun would be a point of light years of travel away even at the speed of light. A galaxy is far more space than substance, mostly dark, mostly silent. The stars set as sparsely through it as a handful of sand grains scattered through a cathedral. The glow you see is real, but it is the glow of countless tiny fires burning across an ocean of dark, each one alone, each one separated from the next by gulfs that dwarf the fire itself. That spaciousness is a comfort rather than a loneliness. Between the stars there is room, endless, untroubled room, and the same is true of the night around you now. Nothing is pressing in, nothing crowding the dark. Those 40 billion suns hang unhurried and unbothered across their wide disk, each in its own broad pocket of space, and you lie here in your own pocket of the night, surrounded by room enough to let every held thing loosen and ease outward into the dark. The constellation that lends the galaxy its name is one of the smallest and faintest in the entire sky. Triangulum is just 3 modest stars arranged in a narrow triangle, so dim and so slight that most people have looked straight past it their whole lives without ever noticing it was there. And yet inside that overlooked little shape hides one of the grandest objects the naked eye can reach. There is a quiet lesson in that the plainest, least regarded corner of the night can hold something immense, and that what is grand is not always what is bright. That little triangle is one of the oldest shapes the human eye has named. It was counted among the constellations by the astronomers of the ancient Mediterranean nearly 2,000 years ago, set down in the earlier star catalogues that survive, and the people of those distant centuries gave it names drawn from the letters and landscapes they knew. Some called it after the 4th letter of the Greek alphabet, the triangular delta. Others saw in it the shape of the great river mouth of the Nile fanning out into the sea. For as long as there have been star maps, this small triangle has held its place in them, and all that while, unseen beneath it, the galaxy waited, its light arriving night after night into eyes that could not yet know what they were receiving. The galaxy itself has gathered a softer, informal name over the years. Some stargazers call it the pinwheel of Triangulum, for the way its open arms turn like the paper wheel a child holds into the wind. It is a fitting image, the spiral caught forever mid-turn, its arms flung outward in a shape made for spinning, though it spins so slowly that no human eye will ever see it move. A pinwheel turning on a clock of hundreds of millions of years, holding so still in the sky that it seems painted there, while in truth every part of it is sweeping grandly around the centre. People have been noticing that faint glow for longer than the telescope has existed. An Italian astronomer named Giovanni Hodierna almost certainly recorded it sometime before the year 1654, sketching it among the cloudy patches of the sky more than 3 centuries ago, long before anyone could have guessed what it truly was. To him it was simply a soft nebulosity, a smudge worth noting near the little triangle of stars. He could not have known he was the first of his kind to set down, in ink, the light of a separate galaxy, an entire island of suns mistaken for a wisp of cloud. A little over a century later, the comet hunter Charles Messier found it again on a late summer night in 1764 and gave it the number it still carries, the 33rd entry in his famous catalogue of faint, fuzzy things that were not comets. He was not looking for galaxies. No one yet knew galaxies existed. He was clearing the sky of distractions, listing every soft glow that might fool a comet hunter into false excitement, so that he and others could pass them by. And so, one of the great galaxies of the local group entered the human record almost dismissively, catalogued as a thing to be ignored. It has been known as Messier 33 ever since. For nearly 200 years after that, no one understood what they were looking at. The soft glow was assumed to be a cloud of gas somewhere within our own Milky Way, perhaps a solar system in the act of forming, a swirl of matter condensing into a star and its planets. The idea that it might be an entirely separate galaxy, millions of light years away, simply had no place in the cosmology of the time. The universe was thought to be small, and the Milky Way was thought to be most of it. That faint spiral smudge sat quietly in the catalogues for generations, its true distance and true nature locked away behind the limits of the lenses then available. The first hint of its real shape came in the middle of the 19th century, when a great telescope in Ireland turned its enormous mirror toward the smudge. Through that instrument, the largest in the world at the time, the observer could see something no one had seen before. The glow was not formless but spiraled, wound into a faint pinwheel of light. It was among the first objects ever recognised to have that swirling shape. No one yet knew what a spiral meant, or how far away it lay. But for the first time a human eye had traced the curve of those distant arms, and understood that this was a structure, turning, with a pattern of its own. The full truth arrived only in the 1920s, when astronomers learned at last to measure the distance to such glows. By picking out certain special stars within the spiral, stars that pulse brighter and dimmer in a steady, predictable rhythm, they could read off the true distance to the cloud, the way you might judge the distance of a lighthouse by how bright its known lamp appears. The numbers that came back were staggering. The smudge was not within the Milky Way at all. It lay millions of light years beyond it, an entire galaxy in its own right, one of countless islands of stars scattered through a universe vastly larger than anyone had dared imagine. In a single stroke, the cosmos grew immeasurably wider, and the faint glow in Triangulum became a far shore across an ocean of dark. That discovery did more than place one galaxy on the map. It built the first rung of a ladder that astronomers still climb to measure the whole universe. Once the pulsing stars of Triangulum and its neighbours gave up a reliable way to read distances across millions of light years, the same method could be stretched, rung by rung, to galaxies far beyond, until the entire scale of the cosmos, out to its faint and ancient edges, could be reckoned from the patient timing of variable stars. The little smudge in Triangulum, and the handful of nearby galaxies like it, became the foundation on which the measured size of everything was raised. From a faint glow in a small constellation, the dimensions of the universe itself. Those special pulsing stars deserve a moment of their own, for they are among the most useful lights in all of astronomy. A certain kind of star swells and shrinks in a regular beat, brightening and dimming over days or weeks, and the slower its beat, the more light it truly gives off. Find one of them, time its pulse, and you know its real brightness. Compare that to how faint it looks, and the distance falls out of the arithmetic. They are the universe's own measuring lamps, and it was such stars glimmering within the Triangulum spiral that first let astronomers reach across the dark and lay a true number against that ancient glow. The galaxy offered up a second kind of measuring tool as well, even more precise. Pairs of stars that circle and eclipse one another, dimming in a perfect rhythm as one passes before the other. By reading the depth and timing of those eclipses, astronomers can work out exactly how large and how bright the two stars truly are, and from that, again, the distance. Using such eclipsing pairs within Triangulum, they measured its distance with remarkable care, refining the ancient glow's remoteness to something near 3 million light-years. Two faraway suns circling each other in a steady dim dance became a ruler long enough to span the gulf between galaxies. There is a quiet wonder in that, in measuring the unreachable by watching it dim. No one could ever travel to those two stars. No instrument could ever reach across 3 million light-years to touch them, and yet, simply by watching their light fade and brighten in its faithful rhythm as one star slips before the other, astronomers learned their true sizes, their true brightness, and from those the true distance to the galaxy that holds them, all of it read from a faint, regular flickering gathered patiently over many nights. The most distant things in the universe give up their secrets not to those who reach them, but to those who watch them carefully enough, for long enough, in the dark. And what those careful measurements reveal is a remoteness the mind can scarcely frame. Even travelling at the utmost speed the universe permits, the speed of light itself, a journey to Triangulum would take the better part of 3 million years. The fastest craft humanity has ever built, by comparison, would need far longer, many billions of years, a span dwarfing the entire age of the Earth, just to cross that single gulf to our near neighbour among the galaxies. The distance is not merely large, it is a distance that turns travel into something closer to geology than to a voyage. And still the light makes the crossing faithfully and arrives. Astronomers found a third clock there too, hidden in the gas. In certain dense clouds within the galaxy, molecules of water act as natural lasers, beaming out radio light in tight, brilliant points called masers. By tracking these master beacons over years, watching the way they shift ever so slightly against the deeper sky, astronomers managed to detect the actual motion of the galaxy across space, not just toward or away, but sideways, drifting against the backdrop of the more distant universe. It is one of the few galaxies whose true motion through space has been measured this directly, its sideways drift teased out from the faint shimmer of water shining in the dark. And what that motion reveals is that Triangulum is not drifting away. Most galaxies, carried apart by the expansion of the universe, show light shifted toward the red as they recede. Triangulum's light is shifted the other way, toward the blue, the signature of something approaching. It is falling toward our corner of the cosmos at well over 150 kilometers every second, drawn by the gravity of the local group. In a universe that is everywhere flying apart, this is one of the rare lights that is coming closer. A galaxy bound so tightly to our own small family that it moves against the great outward tide. Almost everywhere else in the cosmos, the story is one of parting. The vast majority of galaxies are racing away from us, and from one another, carried apart by the steady swelling of space itself, their light reddened by the retreat, the distances between them widening with every passing age. Against that universal drifting apart, the little gathering of galaxies you belong to holds together, pulled inward by its own gravity, immune to the expansion that scatters everything beyond it. Triangulum's approach is a small, local defiance of the great cosmic spreading, a sign that here, in this one quiet neighbourhood, things are not flying apart but leaning gently together, held close across the dark for ages yet to come. Across all that emptiness, this island of suns is not departing but drawing near, slowly, steadily, across spans of time longer than the mind can stretch. The reason it is bound, rather than fleeing, is that it has company. Triangulum lies close, in galactic terms, to the Andromeda Galaxy, the largest member of the local group, separated from it by less than 1 million light-years, far nearer to Andromeda than Andromeda is to us. The two have been neighbours for a very long time, and gravity does not let such neighbours ignore one another. Across the dark between them runs an invisible tension, a slow pull that has shaped the history of both, the larger galaxy and the smaller one leaning toward each other across the gulf like two dancers who have not yet touched. From a world somewhere inside Triangulum, Andromeda would dominate the night. So near as that giant neighbour that it would hang in Triangulum's sky as a great glowing oval many times wider than the full moon appears to us. A luminous presence spread across the dark, bright enough to cast its own faint light, an entire sister galaxy looming close and grand. The beings of such a world, if any exist, would never know a truly empty sky. Always that vast soft wheel of Andromeda would be there above them, the nearest of the great galaxies, far closer to them than Andromeda is to us, a permanent companion in their night. The same closeness means that, from Triangulum, our own Milky Way too would be a visible thing, a fainter, more distant glow than Andromeda, but there nonetheless, another spiral hanging in the dark across the millions of light-years of empty space. 3 great galaxies, each able in principle to see the other two as soft ovals of light in its sky, bound together by gravity into a single intimate family, exchanging nothing but ancient light across the gulfs between them. The whole local group, from any one of its 3 great members, would be a small bright neighbourhood scattered across an otherwise empty dark. The evidence of that long acquaintance is written in hydrogen. Stretched across the space between Triangulum and Andromeda, astronomers have traced faint bridges and streams of neutral hydrogen gas, thin filaments of the lightest element, drawn out into the dark like spun sugar between the 2 galaxies. Such streams are the fingerprints of gravity's pull, gas teased out of the galaxies by their mutual attraction. They suggest the two have passed near each other before, long ago, brushing close enough to draw these threads of gas out into the void where they still hang, a record of an old encounter still faintly glowing. Think of what that bridge of gas truly is, a thin, faint thread of hydrogen reaching across the better part of 1 million light-years, the only physical thing that spans the immense emptiness between 2 galaxies. Everywhere else, the gulf between Triangulum and Andromeda is pure void, but along this one tenuous filament, the two are quite literally connected, joined by a strand of the lightest element drawn out between them like a single fibre stretched across a vast dark room. It is the most delicate of bonds, far too thin to see by eye, and yet it ties 2 great galaxies together across a distance that light itself takes hundreds of thousands of years to cross. A thread of gas, holding hands between worlds of stars. That ancient brush left its mark on Triangulum's very shape. The warp at the galaxy's edges, the gentle lifting and dipping of its outer disk, may well be the souvenir of a close passage by Andromeda billions of years ago, a time when the larger galaxy swept near enough to tug at Triangulum's outer reaches and leave them slightly bent. Galaxies, it turns out, remember. The forces of a single distant encounter can stay written into the curve of a disk for billions of years afterward, a faint flexing in the structure of 40 billion stars that recalls a meeting older than the oldest rock on Earth. Whether Triangulum truly orbits Andromeda, looping around it like a moon around a world, or whether it is only now falling toward it for the very first time, remains an open and lovely question. Some measurements suggest the smaller galaxy has circled the larger one before. Newer ones hint that it may be making its first long approach, dropping inward from far out for the first time in cosmic history. Astronomers do not yet know which story is true, and there is something restful in a mystery of that scale, a question so vast and so slow that it will not be answered tonight or in any human lifetime, and need not be. Some things are simply allowed to remain unresolved in the dark. Whatever its past, its future bends toward the two great galaxies. Far ahead in time, billions of years from now, the Milky Way and Andromeda are fated to fall together and merge into a single greater galaxy. And Triangulum, bound to them both, is expected to be drawn into that slow collision as a third partner, swept up in the merging of the giants. It may join them, or be flung wide and then return, or settle as a small companion to the vast new galaxy that forms. The wheel you're watching tonight is already, imperceptibly, on its way toward that distant union, gliding across the dark toward a meeting that lies further ahead than the Earth itself is old. There is no violence to fear in that thought, though the word collision suggests it. When galaxies merge, the stars within them almost never strike one another. The spaces between suns are so enormous that the two great clouds of stars simply pass through each other, like two flocks of birds crossing in the same patch of sky, each star sliding past the others untouched across light years of room. What changes is the shape of things, by degrees, over hundreds of millions of years, as gravity reweaves the orbits into something new. It is less a crash than a merging of two great tides, two vast and gentle currents folding quietly into one. Imagine it, three galaxies, across unthinkable stretches of time, drawing together by degrees so small that within any single lifetime nothing seems to happen at all. The stars drift, the arms unwind and reform, new nurseries flare where the gas piles up, and across all of it, no sudden shock, no single moment of impact, only the patient arithmetic of gravity working over spans that make a human century look like the flicker of an eyelash. The most enormous events in the universe are also very often the slowest and the calmest. Nothing about them is in any hurry. Let that calm of deep time settle into the breath now, in and slowly out, the unhurried pace of galaxies becoming, for a little while, the pace of your own resting body. Closer in, within Triangulum's own disk, the slow making and unmaking of stars goes on without pause. The galaxy is forming new suns at a steady, healthy rate, gathering perhaps a few tenths of a sun's worth of fresh starlight out of its gas every year, and for its modest size that is a generous, active pace. It is not a dormant or fading galaxy. It is alive with quiet industry, its arms still busy spinning gas into fire, still freckled with the rose-pink glow of regions where the next generation of stars is being kindled even as you lie here. The work of creation in that galaxy has never stopped, and is not stopping now. For its size, in fact, it is one of the busier galaxies of the local group at making stars. Measured patch for patch across its disk, Triangulum kindles new suns faster than its giant neighbour Andromeda does, a smaller galaxy, yet a more eager one, its surface freckled more densely with the rose glow of fresh creation. Andromeda is the larger and grander of the two by far, but much of it has settled into a quieter middle age, while little Triangulum still burns bright with the making of stars. There is something heartening in that, in the smaller and less imposing of the two doing the more vigorous work, alight with creation along every arm. The cold gas from which those stars are made gives off a light all its own, far below the red the eye can see, a faint radio glow from molecules of carbon and oxygen locked together in the frozen clouds. By tuning their instruments to that particular glow, astronomers can find the densest, coldest, most star-ready clouds in the galaxy, the very pockets where the next suns are gathering, even though those clouds are far too dark and cold to shine in any visible light. Only about a tenth of the galaxy's gas has reached that cold, clumped, ready state at any one time. A small reserve of frozen fuel, glimmering only in the invisible, holding the galaxy's future stars in waiting. Spread across its disk are the small, dense, ancient clusters that every great galaxy keeps. Globular clusters, tight balls of hundreds of thousands of old stars, gathered into spheres so crowded that near their centres the night sky would blaze with suns. Triangulum holds dozens of these, perhaps more than 100 all told, scattered through and around its disk like old pearls. They are among the oldest things the galaxy contains, formed in its earliest days, and they have circled patiently ever since, surviving every change the galaxy has passed through, keeping the light of its first ages alive in the dark. Each of those globular clusters is its own small marvel, a swarm of ancient suns so densely packed that, from a world somewhere inside one, there would be no true night at all. The sky from such a place would hold thousands upon thousands of bright stars, near enough and numerous enough to fill the dark with a permanent soft twilight, the way a great city fills its sky with a glow that never fully fades. Whole skies of crowded starlight, gathered into spheres a few dozen light years across, drifting in slow orbits through the outer reaches of a galaxy nearly 3 million light years away. The galaxy keeps a record of its own dying stars as well, written in expanding rings of glowing gas. When a massive star reaches the end of its life and explodes, it leaves behind a shell of debris that races outward for thousands of years, glowing as it goes, a supernova remnant, the slowly fading wound of a stellar death. Astronomers have catalogued around 100 such remnants threaded through Triangulum's disk, each one the lingering echo of a star that ended in fire long ago. They are not grim things to dwell on, but beautiful ones. Delicate, glowing filaments of gas, the scattered atoms of old suns returning to the dark to become, one day, the stuff of new ones. For in a galaxy, nothing is ever truly lost. The gas flung out by a dying star drifts back into the great reservoirs of the disk, mingles with the cold clouds there, and in time is gathered up again into the next generation of suns. Every atom is borrowed, used, returned, and used again, across cycles that turn over hundreds of millions of years. The very iron and oxygen and carbon scattered by Triangulum's old supernovae will one day shine again inside stars not yet born. It is the most patient kind of renewal there is, slow, complete, and endlessly forgiving. A galaxy quietly making itself over and over out of its own remains. Even the rate of those stellar deaths follows an unhurried rhythm. In a galaxy the size of Triangulum, a star ends its life in a great explosion only about once every century or so. A single supernova in the time it takes a human life to begin and end. Across 40 billion stars, the dramatic deaths come so rarely, spaced so widely through the long centuries, that the galaxy as a whole simply glows on, serene, while these immense events flicker through it at intervals longer than empires last. What feels catastrophic up close is, across the whole disk, the rarest and most measured of occurrences, and when one of those distant suns does end, its light takes the same 3 million years to reach us as all the rest, so that the explosions we might catch in Triangulum tonight are not happening now at all, but happened in the deep past, their news only now arriving, long after the star itself has fallen quiet and cooled into the dark. Even the galaxy's most violent moments reach us gentle by time, softened into a faint and distant flickering by the sheer immensity of the road they have travelled. Among all the burning things in that galaxy, one in particular is strange and dark and worth a quiet moment. Within Triangulum sits a pair of objects locked in a tight orbit, a massive blue star and circling close beside it, a black hole. The black hole carries the mass of perhaps 15 or 16 suns crushed into a space smaller than a city, invisible in itself, betraying its presence only by its pull on the bright companion star and by the faint X-ray glow of matter spiralling into it. The two whirl around each other, the visible and the invisible, completing an orbit every few days, one of the heaviest known black holes of its kind born from a single collapsed star. Picture that pairing across the dark, a brilliant blue sun, and beside it a sphere of absolute night so dense that not even light escapes it. The two bound together and turning, every 3.5 days, for as long as either has existed. As the black hole draws a thin stream of gas off its bright partner, that gas heats to a fierce glow before it vanishes over the edge of the dark, sending out a faint regular pulse of X-rays, a slow heartbeat from a place where one star quietly feeds another's grave. It is a fierce thing, and yet at 3 million light-years remove, it too is only a faint and silent point in a great calm wheel. That black hole binary is only the brightest of many such points. Threaded through Triangulum's disk are hundreds of sources of X-ray light, each one a place where matter is falling onto something dense and dark, onto the crushed cores of dead stars, onto small black holes, onto the burning surfaces of stellar remnants drawing gas from a neighbour. To an eye that could see in X-rays, the galaxy would be sprinkled with these hot hidden points, a second constellation laid over the visible one, marking every place where the galaxy's most extreme objects are quietly at work. None of it can be seen by any ordinary eye. It is a whole layer of the galaxy that reveals itself only to instruments tuned to that fierce, invisible light. Among those X-ray points, one or two shine far brighter than the rest, so bright that astronomers once struggled to explain how any single object could pour out such power. These rare, dazzling sources are thought to be places where matter floods onto a black hole at a tremendous rate, blazing in X-rays with the light of millions of suns from a region no larger than a small city. They are among the most luminous single objects in the entire galaxy, and yet they give off almost no light the eye can catch. Their brilliance is poured out entirely in the invisible, a fierce, silent glare hidden inside the calm grey haze. Step back again to the hole, and that wheel grows almost musical in its proportions. The spiral arms wind outward in curves so regular that they trace something close to a logarithmic spiral. The same elegant curve found in the shell of a nautilus, in the seed head of a sunflower, in the arm of a hurricane seen from above. The galaxy is not laid out by accident, but by the deep mathematics of rotation and gravity. The same rules that shape the small and spiralling things of Earth writ across 60,000 light-years of stars. To look at it is to see a familiar pattern made impossibly vast, the curve of a seashell drawn in suns. Those arms are not solid structures but waves, slow ripples of compression that sweep around the disk, piling up gas as they pass and triggering the birth of stars in their wake. The bright arm you see is not a fixed crowd of stars travelling together, but a moving zone of density, like the bunching of cars along a stretch of highway that stays in place while the cars themselves flow through it. Stars drift into the arm, slow, brighten as new suns ignite around them, and drift out the other side. The pattern persists while its contents endlessly change, a standing wave of light turning through a sea of stars. This is why the arms shine so blue and bright. They are the crests where star formation is happening now, lit by the hot young suns the wave has just kindled. Between the arms, the galaxy is dimmer and redder, populated by older stars that long ago drifted out of the bright zones and settled into the quieter spaces between. So the very pattern of the spiral is a map of time and motion, the luminous arms marking where creation is most active, the darker gaps marking where the work was finished long ago and the stars have aged in peace. The gas that feeds all this creation is mostly the simplest substance there is, hydrogen, the first element, forged in the opening minutes of the universe itself. Triangulum is rich in it, its disk laced with great clouds of cold hydrogen waiting to collapse into stars, and ringed even farther out by a vast thin halo of the same gas reaching well beyond the visible light. The galaxy you see is the bright tip of something larger and more tenuous, a luminous disk swimming in a faint sea of primordial gas, drawing on that ancient reservoir to go on making stars long into the future. A small fraction of that gas has gathered itself into something denser and colder, molecular clouds, where hydrogen atoms have paired into molecules and the temperature has fallen close to the absolute zero of deep space. These are the true cradles of stars, the darkest and coldest places in the galaxy, where matter grows still enough and dense enough to begin collapsing under its own weight. It is from these frigid, lightless clouds, colder than almost anything you could ever imagine, near the very floor of cold, that every new sun in the galaxy is born. The hottest things in the universe begin in the coldest cradles. There is a deep symmetry in that worth resting on. The fiercest fires born from the coldest dark, the blaze of a new star condensing out of a cloud near the temperature of the void. Cold gathers the matter, gravity squeezes it, and only when the squeezing grows fierce enough does the cold heart of the cloud finally catch fire and become a sun. Every star you have ever seen began as something freezing and dark and still, and that includes the sun that warms your own world, and every one of the 40 billion suns turning in the galaxy you're watching now. Different parts of the disk turn at different speeds, and the way they turn told astronomers something hidden. If a galaxy were held together only by the gravity of the stars and gas you can see, its outer regions should orbit far more slowly than its inner ones, the way the outer planets of a solar system crawl while the inner ones race. But the outer stars of Triangulum move far too fast for that. They orbit at nearly the same brisk pace as the inner ones, as though held by far more mass than meets the eye. It was measurements like these, across many galaxies, that first revealed the presence of dark matter, that vast invisible scaffolding holding the bright disks together. Triangulum's swift-turning edges are part of that great clue. What it means is that the glowing wheel you see is only a small, bright part of the true galaxy. The greater part is dark and silent, a halo of unseen mass enclosing the light like the deep, invisible bulk of an iceberg beneath its gleaming tip. The stars are the part that shines. The dark matter is the part that holds. And across the whole of the visible universe, this is the rule rather than the exception. The things that glow are the minority, cradled within vast structures of something that does not glow at all, patient and unseen, doing the quiet work of holding everything in place. Return for a while to the surface of that disk, to the rose-coloured nurseries scattered along its arms. There are hundreds of them, large and small, each a place where gas is collapsing into fire. The biggest few are giants, like the great cavern of NGC 604. The smallest are mere knots, single pockets of new stars glowing faintly against the dark. Together they freckle the spiral with warm pink light, and from a distance they trace the galaxy's arms in a dotted line of creation, marking exactly where the slow wave of starbirth is breaking through the disk right now. The most massive young stars in those nurseries are blue-white and ferociously bright, burning through their fuel hundreds of times faster than a star like the sun. They live fast and die young, a few million years from birth to explosion, where a smaller star like ours may shine for 10 billion. So the brilliant blue stars lighting Triangulum's arms are necessarily young, all of them, for none of their kind has ever lasted long. To see a blue star anywhere in that galaxy is to see something recently made, a sun that did not exist when the most recent ice age gripped the Earth, and will be gone again before the next few ice ages pass. Their brief, brilliant lives are what make the spiral arms shine. Because these blue giants burn out so quickly, they never travel far from where they were born before they die. So they stay concentrated in the star-forming arms, lighting them blue, while the slower aging stars drift away into the dimmer spaces between. The colour of the arms is thus the colour of youth, perpetually renewed. As each generation of blue giants burns out, the wave of star formation kindles another, keeping the arms forever blue across billions of years, even as the individual stars within them come and go like sparks above a fire. The sun that lights your own world is not one of these blue giants, and that is a quiet kind of fortune. It is a modest yellow star, middle-aged and steady, the sort that burns slowly enough to shine for 10 or 11 billion years without much change, long enough for worlds to form and oceans to gather and life to take its unhurried time arising. The fierce blue suns of Triangulum's nurseries blaze far brighter, but they are gone in a cosmic instant. It is the smaller, calmer stars here and in that distant galaxy alike that endure long enough for slow things like planets and patience to take hold. Among the 40 billion suns turning in that disk, the overwhelming majority are small and cool and dim, red dwarf stars far less brilliant than the sun, burning their fuel so sparingly that they will shine for trillions of years, long after the brighter stars have all died away. They are too faint to pick out from this distance, lost in the general glow, yet they are the true population of the galaxy, its quiet and enduring majority. The bright blue giants catch the eye, but it is these patient little embers that will still be glowing when the universe itself has grown old and dim. And around those 40 billion suns, in all likelihood, turn worlds beyond counting. If the stars of Triangulum are anything like the stars of our own galaxy, and there is every reason to think they are, then planets must circle most of them, billions upon billions of worlds scattered through that distant disk. Rocky worlds and gas giants, frozen worlds and molten ones, worlds with rings and worlds with moons, worlds that have never been seen and never will be, turning quietly around their suns across 3 million light-years of dark. The galaxy is not only a city of stars, but a city of worlds, uncounted and unknowable, each one a place with its own dawns and seasons, its own long, slow turning, entirely unaware of the small blue planet that wanders about it tonight. Somewhere among that uncountable multitude of worlds, it is hard not to imagine, conditions might be gentle enough for something to stir. Some warm sea under a distant sun, some slow chemistry beginning its patient work, in a galaxy whose light set out before life on Earth had taken its present shape. No one knows, and perhaps no one ever will. But the sheer number of worlds makes the thought a quiet companion rather than a lonely one. That the great glow you're watching may not be only fire and stone and gas, but here and there, on some warm shore beneath an alien sky, the faint first stirrings of life, looking up, perhaps, at a galaxy of their own. That thought stretches time almost past holding, stars that will outlast the age of bright galaxies entirely, still faintly burning in a cosmos gone dark and cold, 10,000 billion years from now. The small dim suns of Triangulum and of every galaxy are the universe's long memory, the last lights that will remain. There is no rush in such a life. A red dwarf measures its existence in spans that make the current age of the universe look like a single morning, and it spends every one of those years simply, steadily, giving off its modest red light into the dark. Scattered between the stars here and there across the disk drift the strangest single objects the galaxy holds, the remnants of stars that have already died. Some are white dwarfs, the glowing cinders of dead suns no larger than a small planet yet as heavy as a star cooling slowly toward darkness over ages. Others are neutron stars, the crushed cores of greater suns, packing more than the sun's whole mass into a sphere the size of a city, so dense that a thimble of their substance would weigh as much as a mountain. These are the ghosts of the galaxy, the fossils of finished stars drifting silent and unimaginably dense through the dark between the living suns. A neutron star is among the most extreme things the universe can make, and Triangulum surely holds them by the thousands, unseen. Picture a sphere a dozen miles across spinning sometimes hundreds of times a second, holding within it more matter than the entire sun, a single spoonful of which would outweigh all the people who have ever lived. They are the dense, dark seeds left when massive stars collapse, and they drift through that galaxy as they drift through ours, the silent endpoints of stellar lives, packed tighter than anything but a black hole, turning in the dark. That immensity of compression rests against the looseness in your own limbs now. The universe holds both the impossibly dense and the wholly unburdened, and tonight you are the second of these, growing lighter, growing slower, sinking. The galaxy's gas does not sit still, even where no stars are forming. It moves in great unhurried currents, fountains and flows. Hot gas, heated by the winds and explosions of massive stars, rises up out of the disk in vast plumes, cools in the heights, and rains back down again, a galactic fountain, turning over the substance of the disk across millions of years. The whole galaxy breathes, in its way, drawing gas up and letting it fall, circulating the raw material of stars through a weather so vast that no single lifetime could ever watch it unfold. It is the calmest weather imaginable, a single breath drawn across 100 million years. That ceaseless circulation keeps the galaxy fertile. Gas that rises and falls, mixes and cools, is gas made ready to form new stars. A galaxy that could not stir its own material would soon exhaust the cold clouds it began with and fall dark. Triangulum's gentle fountains and flows keep its reservoirs replenished, folding old gas back into cold clouds where it can collapse anew. It is a system in sustaining motion, neither still nor hurried, turning its own substance over and over the way a river turns its bed, keeping itself alive across spans of time without end. There are dark gaps in the disk where almost no stars shine, great holes and shells in the gas, blown clear by the combined winds and explosions of clusters of massive stars. These are not empty in the way the void between galaxies is empty. They are cavities carved into the gas, ringed by the bright rims where the swept-up material has piled and begun forming new stars of its own. So even destruction, in a galaxy, sows creation. The same blasts that blow a hollow in the cloud compress its edges and light them with new suns. The wound and the healing are the same act, written in gas and light across the disk. Seen from far enough away, all of this, the arms, the nurseries, the fountains, the dark shells, the slow turning, resolves into a single calm image, a soft pinwheel of blue and rose and gold, hanging motionless against the black. All the fierce activity, all the explosions and collapses and racing winds, all of it averages out across the vast distance into perfect stillness, a quiet, glowing wheel that seems never to change at all. The most turbulent place imaginable, viewed from far enough off and unhurried enough in the watching, becomes the very picture of peace. So it is with many things, so perhaps it is with the mind, when it is finally allowed to be watched from a great enough distance, and all of it unfolds in absolute silence. Sound needs air or water or some substance to carry it, and between the stars there is almost nothing at all. So the explosions of dying suns, the collisions of vast clouds, the grinding of a galaxy's whole machinery, every bit of it happens without the faintest whisper. The most enormous events imaginable take place in a stillness more complete than any silence ever known on Earth. A quiet so total that it has never once been broken in all the galaxy's billions of years. The wheel turns, the stars are born and die, the arms sweep around, and not a sound escapes into the dark. It is the most peaceful kind of grandeur there is, immense, ceaseless, and utterly without noise. There is a deep restfulness in imagining that, a place where the greatest things happen in perfect quiet, where nothing clamours, where even the death of a star is soundless. The galaxy makes no demand on the ear, as it makes none on the hand or the mind. It simply turns in its great silence far away, asking to be neither heard nor answered, and the quiet of it can settle into the room around you now, into the space behind the eyes, into the slow and soundless rhythm of the breath. The light reaching you from that wheel tonight is, in a real sense, a fossil. It left the galaxy millions of years ago and has been travelling ever since, so that what you see is not the galaxy as it is now, but the galaxy as it was. An image of the deep past arriving only now in your present. The triangulum you're watching may have changed in all the ages since. New stars born, old ones died, the arms turned onward. But none of that news has reached you yet. You're seeing a portrait of a younger galaxy, painted in light that set out before your species had a name. Follow a single particle of that light on its long passage. One photon leaves the surface of a star in Triangulum, set loose into the dark, and then for nearly 3 million years it travels in a perfectly straight line through the emptiness, meeting nothing, touching nothing, neither slowing nor tiring, crossing the entire gulf between two galaxies alone. Whole ages of the Earth rise and pass while that one speck of light is still in flight. And its journey ends, after all that time and all that distance, in the only way such journeys can end, by striking the back of an eye in a darkened room on a small blue world, giving up the whole of its long voyage in a single silent instant of being seen. Every faint glimmer you catch from that galaxy is the close of a journey almost as old as the human story, and they arrive not one at a time but in a soft, steady rain. Even from a glow so faint, countless such photons fall on your open eye each second, a continuous fine drizzle of ancient light, every drop of it having crossed the same immense dark, every drop ending its 3 million year passage against your retina in the same quiet way. You are, lying here in the dark, being gently rained upon by the light of 40 billion suns, a rain so soft and so faint that you feel nothing of it at all, though it has been falling on this world night after night, since long before there was anyone here to stand in it. This is true of everything you ever see in the night sky, but it is most striking here, at the edge of what the unaided eye can reach. The farther away a thing is, the deeper into the past you're looking when you see it. To gaze at this galaxy is to look almost 3 million years backward in time, to receive an image so old that the creature receiving it had not yet evolved when the image was made. There is no machine for time travel grander than a dark sky and an open eye. To look out into space is always and unavoidably to look back into time, and the looking runs both ways in a sense across that same gulf. If anyone were watching the Earth tonight from a world somewhere in Triangulum, they would not see the Earth as it is. They would see it as it was nearly 3 million years ago, a planet of early, upright wanderers who had not yet built a single wall, under continents arranged not quite as they are now. The light leaving Earth tonight will not arrive in that galaxy for another 3 million years, long after everyone now alive has gone. Distance, in the cosmos, is also a kind of mercy. It keeps every far place locked gently in its own past, untroubled by the present. A single thread of ancient light, then, binds you to a distant galaxy, and the thread runs both ways and asks nothing of either end. The galaxy turns and you turn with it in a manner of speaking. You sit on a planet circling a star that is itself sweeping in a great orbit around the centre of its own galaxy, carried along at well over 500,000 miles an hour through the dark. You're never truly still. Even lying motionless in bed, you're racing through space, turning with your star, drifting with your galaxy through the local group, the whole system in slow, majestic motion, and yet you feel none of it. The motion is so smooth, so vast, so utterly unbothered that it registers as perfect rest. You're hurtling through the cosmos at this very moment, and the only sensation it produces is the feeling of lying perfectly, peacefully still. Triangulum is doing the same, racing through space, turning on its axis, falling toward Andromeda, carried with the whole local group through the wider universe, and it too betrays no sign of haste. From here it is a still grey glow. Up close it is a maelstrom of motion in every direction at once. Both of these are true. The galaxy is simultaneously the most violently moving thing you can imagine, and the most perfectly serene, depending only on how far away you stand and how slowly you're willing to watch. There is no contradiction in it. It is simply what stillness looks like when it is large enough. Far out beyond the bright disk in the galaxy's faint and lonely halo, the stars grow sparse and ancient. Here, in the galaxy's outermost reaches, the few stars that exist are among its oldest, scattered so thinly that each one hangs in near total isolation, light years upon light years from the next. The halo is the galaxy's memory of its own beginning, populated by stars that formed in its earliest days and have wandered its outskirts ever since, far from the busy star-making arms. It is the quietest part of the galaxy, the still pond beyond the turning of the wheel, where almost nothing has changed in billions of years. A star adrift in that outer halo would have a strange and beautiful view. From there, the bright disk of the galaxy would hang across the sky as a vast luminous wheel, seen edge-on or at an angle, the way the band of the Milky Way arches across our own night, but grander, the whole structure of the galaxy laid out in a single sweep of light, with the dark of intergalactic space yawning beyond it. To live in the halo would be to live forever on the shore of one's own galaxy, looking in at all that turning light from a great and silent distance, never quite a part of the crowd. Down inside the disk among the spiral arms, the view would be different again, and strangely familiar. A creature on a world there, looking up on a dark night, would see a faintly glowing river of countless stars stretched in a great circle around the whole sky. The combined light of the galaxy's own disk, seen edge-on from within, exactly as we on Earth see the pale band of our own galaxy overhead. They would have their own version of that misty arch, their own ribbon of distant suns dividing their sky, and they would likely tell their own stories about it, never guessing it was the flattened wheel of the very galaxy they lived inside. To dwell within a spiral is to be unable to see its shape, to live inside a glowing disk and perceive it only as a band of light, the way a fish in a river cannot see the river entire. Brighter still, in their sky, would be the great rose nurseries, the nearest of which might glow as a soft, luminous patch among the stars, the place where new suns were being kindled close enough to show as more than a point. And scattered through the dark would be the ancient globular clusters, hanging like distant lanterns above and below the disk. The night sky of a world in Triangulum would be a thing of its own particular beauty, unlike any sky on Earth, and yet built of the very same kinds of light. Stars and clusters and glowing clouds, arranged into patterns no human has ever seen, turning slowly through the long nights of a planet 3 million years away. The space between Triangulum and the rest of the local group is among the emptiest places that exists, a near-perfect vacuum, colder and more silent than anything found on any world, where atoms are so sparse that one might travel a long way before meeting another. And yet even there, the galaxies are bound to one another by gravity across those immense gulfs, held in a single loose family by a force that reaches effortlessly through the deepest emptiness. Nothing in all that void can block gravity or slow it. It spans the dark unimpeded, tying the far galaxies to the near ones across distances light itself takes millions of years to cross. It is worth resting on how much of the cosmos is in fact this gentle emptiness. The galaxies, for all their billions of stars, are tiny bright islands, separated by oceans of nothing far vaster than themselves. If the Milky Way and Triangulum and Andromeda were 3 lit lanterns, the dark between them would be a sea wider than all the lanterns laid end to end many times over. The universe is mostly room, calm, dark, untroubled room, and the bright things in it, galaxies and stars and worlds and you, are the rare and precious exceptions, small warm sparks scattered thinly through an immensity of peaceful dark. Within that immensity, the local group itself is only a modest village. Our small family of galaxies belongs to a far larger gathering, drifting toward greater clusters and superclusters of galaxies, vast assemblies bound by gravity across spans that dwarf even the gulf to Triangulum. And those in turn are strung along still grander structures, long filaments and walls of galaxies threading through the cosmos, with great dark voids between. Triangulum and the local group, and you, are a single small bright knot in a web of light and dark so large that the mind can only gesture toward its scale before letting go. And letting go here is exactly the right thing to do. The shape of that great cosmic web came from the faintest beginnings. Tiny ripples in the early universe, slight unevennesses in the spread of matter, that gravity has been patiently amplifying ever since. Where matter was a little denser, more gathered. Where it was thinner, it emptied. Over billions of years, those small initial differences grew into galaxies and clusters, and the vast filaments between, all of it sculpted by gravity out of the gentlest of beginnings. Triangulum exists because, in the universe's first moments, one small patch of space held very slightly more than its neighbours. From a whisper of unevenness, a galaxy of 40 billion suns. It is a strange comfort that everything grand grew from something almost imperceptibly slight, that the great spiral you're watching traces its existence back to a faint ripple in the early dark, a difference so small it would have seemed like nothing at all. The cosmos builds its largest things with infinite patience out of the smallest seeds, asking only time, vast quantities of time, and applying gravity's gentle, unrelenting pull. There is no hurry anywhere in the process. A galaxy is what a whisper becomes when it is given billions of years to grow. The hydrogen that fills Triangulum's disk, the raw material of all its stars, is itself almost as old as the universe. It was forged in the first few minutes after the beginning, when the entire cosmos was hot and dense enough to cook the lightest elements out of pure energy. Every hydrogen atom in that galaxy, in every glowing nursery and cold dark cloud, is nearly 14 billion years old, a relic of the universe's first quarter of an hour. When you look at the rose-pink glow of NGC 604, you're watching the most ancient material there is being kindled at last into something new. The heavier elements came later, and they came from the stars themselves. Carbon, oxygen, iron, gold. None of these existed in the early universe. All of them were forged in the hearts of stars and scattered by their deaths, generation upon generation, slowly enriching the gas of every galaxy. So the gas in Triangulum today is not the pure hydrogen of the beginning, but a richer brew, seasoned by the ashes of countless dead stars, ready to make new suns and perhaps new worlds, with the ingredients of rock and water and life. Each generation of stars cooks the elements for the next. The galaxy is a slow forge, turning starlight into substance across the ages. This is the quiet truth that joins you to that distant wheel of light. The atoms in your own body, the calcium in your bones, the iron in your blood, the oxygen filling your lungs as you breathe slowly now, were every one of them forged inside stars, scattered by stellar deaths, and gathered up again into worlds and creatures. The same process that lights Triangulum's nurseries built the hand resting on the blanket. You're made of the ashes of old stars, and so is that galaxy, and so is everything. Across 3 million light years, you and the wheel of light are kin, assembled from the same ancient fire. Let that kinship settle softly through the body now, that you're not separate from the distant stars, but made of the very same stuff, resting here, a small warm gathering of starlight grown briefly able to look back at the sky it came from. Within the great rose nurseries, the newborn stars are often still wrapped in the gas and dust from which they formed, hidden inside dark cocoons that glow only faintly in infrared light as the warmth of the young star seeps through. It can take a star a long while to clear away the cloud of its own birth, to blow back the surrounding gas with its light and winds until at last it shines out plainly into space. So the youngest stars of Triangulum are, many of them, invisible even to the sharpest telescopes, swaddled in dark, glowing only as gentle heat, suns not yet ready to be seen, taking their slow time to emerge. There is a tenderness in that image, if you let there be, a star, just born, resting hidden in the dark of the cloud that made it, in no hurry to shine. It will emerge when it emerges, blow back its cocoon when it is ready, and not a moment before. The universe does not rush its newborn suns. They gather their fire slowly in the dark, wrapped warm in the gas of their making, and only when the time is right do they break free and take their place among the visible stars of the spiral. The dust that wraps those young stars is itself a marvel of smallness, grains finer than smoke, each a fraction of the width of a human hair, made of carbon and silicates and ices condensed in the cold of space. There is an unimaginable number of these tiny grains spread through the galaxy, and together they do enormous work. They shield the cold clouds from starlight, allowing them to grow cold enough to collapse. They provide the surfaces on which simple molecules assemble, and one day, gathered together, they become the rocky cores of planets. The smallest things in the galaxy are the seeds of the largest. Worlds begin as dust. Some of that dust drifting in the cold dark clouds is gathered into molecules more complex than hydrogen, simple compounds of carbon, water ice, the first faint chemistry of the cosmos. Out in the frozen reaches of Triangulum's molecular clouds, as in our own galaxies, the raw ingredients of more elaborate chemistry are quietly assembling on the surfaces of dust grains, in the dark, at temperatures near the absolute bottom of cold. The galaxy is not only making stars, it is making in its cold clouds the molecular alphabet from which more intricate things might one day be spelled. It is humbling to think that the same kinds of clouds, in our own galaxy, gave rise to the sun and the earth, and eventually to the slow breath moving in and out of your chest right now. Triangulum's cold clouds are doing the same work this very moment, in their own time, across nearly 3 million light-years of dark, collapsing, warming, forming stars and perhaps the seeds of worlds, following the same patient recipe that once, here, produced a small blue planet and everything that has ever lived on it. The process is universal. What happened here is happening there and will go on happening long after. The light from those distant star-forming regions, when spread out into its colours, reveals the exact chemistry of the gas. For each element, when it glows, gives off light at its own particular set of colours, a fingerprint no other element shares. By reading those fingerprints in Triangulum's light, astronomers can tell precisely what its clouds are made of, how hot they are, how fast they move, all without ever leaving Earth. A beam of ancient light, broken into its colours, carries within it a full and honest report of a place 3 million light-years away. The galaxy tells its secrets freely to anyone who knows how to read colour. That same trick of reading colour is how astronomers know the galaxy is approaching rather than receding. For motion too, shifts the colours of light, sliding them toward the blue when a thing draws near and toward the red when it recedes. Triangulum's fingerprint of colours is shifted slightly blue, and that small shift, measured with great care, reveals its approach across the dark. A glow that left the galaxy millions of years ago still carries, encoded in the exact placement of its colours, the news of which way the galaxy was moving when the light set out. Light remembers everything and tells it plainly. There is a particular hue, deep in the red, that the glowing hydrogen of those nurseries gives off most strongly. A colour astronomers know intimately, the signature glow of hydrogen returning to rest after being lit. It is this red that makes the great star-forming regions of Triangulum blaze rose and crimson in long exposed images, the unmistakable colour of creation in progress. Everywhere you see that deep, warm red threaded through the galaxy's arms, you are seeing hydrogen, the oldest and simplest element, glowing with the light of brand new stars, the colour of the universe's first material lit by its newest fires. If you could stand within the galaxy, near one of those great glowing nebulae, the gas around you would be so thin that you would scarcely know it was there, far thinner than the best vacuum ever made on Earth, a near emptiness only made visible by the sheer depth of it, light-years upon light-years of faint gas adding up to a visible glow. The nurseries look solid and bright from a distance, like banks of luminous cloud, but they are almost entirely empty space, glowing softly only because they are so vast. What seems a substantial thing is mostly room. The galaxy's grandest structures are made, in the end, of the gentlest stuff there is. That is a recurring lesson of the cosmos, and a restful one, that immensity and emptiness go together, that the largest and most beautiful structures are also the most spacious and the least crowded. There is nothing dense or heavy or pressing about a galaxy, despite its 40 billion stars. It is mostly silence, mostly room, mostly the calm dark through which a thin scatter of light is spread. To picture it truly is to picture spaciousness itself, vast and unhurried, and to feel perhaps a little more spacious within. The colours of a galaxy's stars taken all together can even reveal its age and history, for a galaxy full of young blue stars glows differently than one full of old red ones, and Triangulum's particular balance of colour tells astronomers it is still vigorously forming stars, still young at heart for all its billions of years. It has not yet settled into the reddish quiet of an old exhausted galaxy. Its light is the light of a place still making things, still kindling new suns along its open arms, a galaxy in the long and active middle of its life, in no danger of running down any time soon. How long is the life of such a galaxy? Far longer than the present age of the universe. Triangulum has been forming stars for billions of years already, and with its great reservoirs of cold hydrogen, it will go on forming them for billions more, until, in some far future, its gas at last runs thin, and the bright blue arms slowly fade to the soft red glow of aging suns. But that lies almost unimaginably far ahead. For now, and for ages to come, the galaxy is in its long flowering, its arms are light, its nurseries warm, making suns at its own steady and unhurried pace. When that far day finally comes, the change will be so gradual that no single moment will mark it. Over billions of years, the blue will fade from the arms, generation by generation, as the gas thins and fewer new stars are born to replace the bright giants that burn out. The spiral will slowly redden, its fierce young suns giving way to the calm gold and deep red of age, until at last it shines with the soft, even glow of an old galaxy at rest, its making mostly done. There is no sorrow in that ending, only a slow settling into quiet. A galaxy that spent tens of billions of years pouring out new stars, easing at last into a long and peaceful dusk, still glowing, still turning, simply no longer building. And yet even then it will not go dark. The small red dwarf stars, so frugal with their fuel, will go on burning for trillions of years more, long after the last bright giant has died and the gas has all been spent, keeping the old galaxy faintly aglow into a future so distant that the universe itself will have changed beyond recognition. Whatever becomes of Triangulum, whether it merges with the giants or drifts on alone, those patient embers will carry its light forward almost without end. The last faint warmth of a galaxy that once blazed with creation, glowing quietly on into the deep, far night of the cosmos. The very oldest stars in Triangulum, the ones gathered in its ancient globular clusters and scattered through its faint halo, are nearly as old as the universe itself, stars that formed in the first billion years after the beginning, when the cosmos was young and galaxies were only just assembling. These ancient suns have been burning for well over 12 billion years, witnesses to nearly the whole history of everything. They formed before the sun, before the earth, before most of the stars that now exist, and they are burning still, the galaxy's long, faithful memory of its own deep origins. Imagine a single one of those old stars far out in the halo that has shone steadily for 12 billion years, through the formation of the sun, the birth of the earth, the rise and fall of every living thing that has ever existed on a planet it will never know, all of it a brief flicker against the long, even light of that ancient sun. Such stars put every human measure of time into proportion. A life, a civilization, an age of the earth. All of these are moments, against a star that has burned quietly since the universe was new, and will burn on long after the present age has been forgotten. The galaxy as a whole assembled slowly, over billions of years, from smaller pieces, clouds of gas and lesser clumps of stars drawn together by gravity, merging gradually into the spiral you see. Galaxies are not born whole, they grow, gathering material across cosmic time, building themselves up from fragments into the great structures they become. Triangulum's current shape is the result of billions of years of patient assembly, gas falling in, smaller companions absorbed, the disk settling and flattening and beginning, at last, to turn as one. What you see is not a finished thing, but a long work still in progress. And it is still growing, still gathering gas from the thin halo around it, still slowly building. A galaxy is never truly complete. It draws in fresh material from its surroundings across billions of years, feeding its star formation, adding gently to its mass. Triangulum continues to accrete the diffuse gas of its outskirts, pulling it slowly inward to make new stars, the way a slow tide gathers sand. The wheel you watch tonight is not a static monument, but a living, feeding system, quietly drawing its substance inward and turning it, in no hurry at all, into light. The steadiness of that settles into you now, a thing that has been gathering and turning and shining for billions of years, that will go on for billions more, asking nothing, hurrying nowhere, simply continuing. Your breath falls into that long, even rhythm, and the day's small urgencies grow faint beside it. The light that Triangulum sends out spreads in every direction at once, filling space with an expanding sphere of its glow, so that the galaxy is, in a sense, sending its image to every point in the universe simultaneously. The tiny fraction of that light that happens to fall on Earth, on the eye of someone lying awake in the dark, is an almost impossibly small sliver of the whole, a few stray photons out of an outpouring that bathes the entire cosmos. And yet those few are enough to carry the full picture of the galaxy across 3 million light-years and paint it, faint and complete, on the back of a single resting eye. There is something almost generous in that, in the way light is given. The galaxy does not aim its glow at you, it simply shines in all directions endlessly, and you happen to be in the path of an infinitesimal part of it. Its light falls on everything equally, the watching and the unwatching alike, the seas of empty space and the rare dark eye turned upward. It pours itself out into the void without preference and without expectation, and asks for nothing in return, and that perhaps is the most restful kind of giving there is. Even the act of seeing the galaxy is a small marvel of patience. The light is so faint that the eye must adjust for many minutes in the dark before it can be caught at all, the pupil widening, the retina growing slowly more sensitive, until the faintest glow at last becomes visible where before there was only black. You cannot rush the eye into seeing it. You can only wait in the dark and let the eye open itself gradually to the faint ancient light, until the smudged surfaces of its own accord. It rewards only stillness and time, and once seen, it is best held not by staring straight at it, but by looking just to the side. For the faintest things in the night are seen most clearly by the edge of the eye, by a soft and indirect gaze rather than a fixed and forceful one. Look directly at the galaxy and it vanishes. Look a little away, and it appears. There is a gentle wisdom in that small trick of vision, that some things are caught only by not grasping at them, held only by a loose and sidelong attention, present only to the gaze that does not try too hard. The faint glow asks to be received, not seized. The whole galaxy hangs in a part of the sky that, to the unaided eye, looks nearly empty. A quiet stretch of the autumn heavens with few bright stars, the little triangle of Triangulum the only modest marker. There is no blaze of brilliant suns around it to announce it, no obvious signpost. It rests in an unregarded corner of the night, easily overlooked, waiting in the dark for the rare eye that knows where to look and is willing to wait. The grandest thing in that patch of sky is also the faintest, and it keeps its own quiet counsel among the dim stars. To find it, stargazers learn to use the brighter stars nearby as guides, hopping from one familiar point to the next until they arrive at the right empty-seeming patch of sky, and then waiting for the glow to emerge. It is a small ritual of patience and orientation, this finding of the faint galaxy, a slow navigation by the dim lights of autumn toward a destination that reveals itself only to the prepared and waiting eye. And when at last the soft oval surfaces out of the dark, there is a particular quiet satisfaction in it, the reward of having looked carefully at a sky most people only glance at. Even a humble pair of binoculars transforms it. To the unaided eye, the galaxy is at best a barely there smudge, but gather a little more of its light through two small lenses, and the haze grows broader, rounder, more clearly a glowing disk than a mere stain on the dark. With a modest telescope on a fine night, the brighter knots begin to show. The Great Rose Nursery NGC 604 surfacing as a faint patch within the larger glow, the first hint of the spiral structure emerging. Each increase of patient gathering peels back another layer, the same galaxy yielding more and more of itself the more light is collected from it, like an image slowly developing in the dark. There is a curious thing in how its brightness is reckoned. By one simple measure, Triangulum should be among the easiest of galaxies to see, bright enough on paper to be an obvious target, and yet in practice it can be one of the trickier ones to catch, precisely because that light is spread so thinly across so wide a patch of sky. A bright thing smeared across a broad area can be harder to see than a faint thing gathered to a point, the way a lamp behind a wide sheet of frosted glass can be dimmer to the eye than a single distant candle. The galaxy's faintness is not a lack of light but a generosity of spreading, all its glow given out across so wide a face that no part of it blazes. Among the galaxies near enough to study in detail, Triangulum is precious to astronomers precisely because of its tilt, because it shows them its face so openly, letting them map its arms and nurseries and individual bright stars in a way that an edge-on galaxy never could. It is a kind of open book, a nearby spiral laid flat for inspection, and from it astronomers have learned a great deal about how spiral galaxies are built, how they form their stars, how their arms and disks behave. Its willingness to be seen has made it one of the best studied galaxies in the entire sky. Seen in the warmth of infrared light, rather than the light the eye knows, the galaxy changes its face entirely. Where visible light shows the blue-white sparkle of stars, infrared reveals instead the glow of warm dust, the fine grains scattered through the disk, heated gently by the starlight around them, shining softly in a colour no eye can perceive. In that light the spiral arms blaze along their dust lanes, and the whole pattern of the galaxy's cool material is laid bare, tracing exactly where the cold clouds and future nurseries lie. It is as though the galaxy keeps several different portraits of itself, each painted in a different kind of light, each revealing what the others hide, the bright stars in one, the warm dust in another, the cold gas in a third, all of them the same quiet wheel. In the long exposed images taken by the great telescopes, Triangulum reveals a richness invisible to the eye. Thousands upon thousands of individual stars resolved across its disk, the rose nurseries glowing in detail, the dark dust lanes winding, the whole structure laid out in colour and depth. What the naked eye catches only as a grey smudge becomes in those images one of the most beautiful objects in the sky, a perfect open spiral, freckled with pink and blue and gold, turning serenely against the black. The faint smear and the glorious pinwheel are the same object, only the patience of the instrument differs. When the finest space telescopes turned toward it and gathered its light for hour upon hour, they resolved the grey haze into a staggering catalogue of individual suns, tens of millions of separate stars, each one picked out as its own point of light, spread across one of the largest and most detailed portraits ever made of a galaxy beyond our own. Where your eye finds a single smudge, those instruments find a teeming multitude, sun after sun after sun, more than a person could count in many lifetimes, all of them part of the same soft glow you might just catch on a dark night. The faint oval and the catalogue of millions are one and the same, a difference made entirely of patience and the willingness to gather light long enough. Even our own galaxy stands between you and that view, dimming it. The light from Triangulum, before it ever reaches your eye, must pass through the outer dust of the Milky Way, the thin haze of our own galaxy's disk, which absorbs and reddens a little of the ancient glow on its way through. So the faintness you see is owed partly to distance and partly to this last veil close to home, a final thin curtain of our own galaxy's making. The light crosses 3 million years of empty space almost untouched, only to be softened in its final thousands of years by the dust of the very galaxy it is arriving in. It is worth holding both of those images at once, the humble grey haze that you might just catch with your own eye on a dark night, and the magnificent jewelled spiral that lies hidden within it, waiting in the faint light for an instrument patient enough to gather it. The grandeur was always there. It is only that the eye, glance, cannot collect enough of the ancient light to reveal it. The galaxy is far more beautiful than it lets on at first, as so many faint and distant things turn out to be when something takes the time to gather their light. The galaxy has no sound, of course. Space carries no sound, and the great turning of those 40 billion stars unfolds in perfect silence. But astronomers, listening with radio telescopes, can pick up the faint hum of its hydrogen gas, the soft radio glow that cold hydrogen gives off across the whole disk, and by translating that signal they can, in a sense, hear the galaxy's structure. The spinning disk, the streams reaching toward Andromeda, the warp at the edges, all of it is written in radio light, a silent music that fills the dark and tells, to those who can detect it, the whole slow story of the galaxy's motion. That radio glow of hydrogen is one of the most useful signals in all of astronomy, for it reveals the gas that no visible light can show, the cold, dark, star-forming reservoirs, the thin halo, the streams between galaxies. Through it, astronomers have mapped Triangulum's hidden gas far beyond its glowing disk, tracing the galaxy's true extent in a kind of light the eye can never see. The galaxy you can see is only the visible verse of a much longer song, and the radio hum of its hydrogen sings the rest, out into the dark where no star shines. Beyond even that lies the galaxy's invisible halo of dark matter, detectable not directly, but only through the motion it commands, the swift orbits of the outer stars, the way the whole disk holds together as it turns. This unseen mass outweighs all the visible stars and gas many times over, the silent majority of the galaxy, present everywhere and visible nowhere. It is a strange and humbling thought, that most of what holds Triangulum together is something no telescope has ever directly seen, known only by the gentle, steady pull it exerts on everything that shines. Most of the universe, in fact, is made of things that do not shine, dark matter that gives no light, and a stranger dark energy that fills all of space and gently pushes it to expand ever faster. The bright galaxies, Triangulum among them, are a tiny luminous fraction floating in a cosmos overwhelmingly composed of the invisible. The light is the exception, the dark is the rule, and yet the dark is not empty or fearful. It is simply the vast, calm, unseen substance of the universe, within which the rare bright things, galaxies and stars and small breathing creatures are cradled. It is oddly soothing that the cosmos is mostly dark and mostly calm and mostly unseen, that the night is not an absence but a fullness, brimming with invisible substance, holding the bright things gently in place. The dark between the stars is not nothing. It is the greater part of everything, the patient unseen body of the universe, and the few lights scattered through it, including the soft glow of Triangulum and the small warm dark of this room, are held within it, supported by it, never falling, never lost. Let that holding hold you now. The dark of the room, the dark of space, the same gentle, supporting dark, asking nothing, letting you rest. The galaxy's spiral arms, traced carefully, are not perfectly smooth but slightly broken and feathered, made of many smaller spurs and branches rather than 2 or 3 clean sweeping lines. This kind of structure, found in many spirals, is called flocculent, like a fleece, soft, woolly, many-stranded, the arms breaking into a multitude of small bright tufts rather than holding to grand unbroken curves. Triangulum wears a touch of this fleecy structure, its arms a little ragged and many-threaded, woven from countless small star-forming knots into a softer, more textured spiral than the clean grand designs. There is a beauty in that softness, in arms made of many small bright pieces rather than a few great strokes. It gives the galaxy a downy, intricate texture, a sense of being woven rather than drawn, every part of the arm composed of smaller parts, down and down to the individual glowing knots of new stars. To look closely at the spiral is to find it endlessly detailed, soft-edged, intricate. Not a simple shape, but a vast and finely textured fabric of light, woven over billions of years from the births of countless suns. The disk of the galaxy is astonishingly thin, in proportion. For all its 60,000 light-years of breadth, it is only a few hundred light-years thick through most of its span, a wheel far wider than it is deep, flat as a great luminous coin. Seen edge-on, a galaxy like this would appear as a thin, bright line with a faint glow above and below. Seen face-on, as Triangulum is, that thinness is hidden, and the disk shows only its broad turning face. You're looking down at the flat of the coin, where its remarkable slenderness does not show, a structure vast beyond measure across, and yet, in the other direction, gracefully shallow. Set those two dimensions side by side, and the proportion grows almost delicate. Compared to its enormous width, the disk is thinner, in relative terms, than a sheet of paper, a vast luminous film of stars, broad beyond comprehension, and yet, for its breadth, exquisitely fine, like a great still pool whose surface stretches to the horizon, while its depth is only a hand's span. There is a fragility to that image, and a grace. 40 billion suns arranged not into a solid ball, but into a wide, thin, turning sheet of light, spread out across the dark with the delicacy of gold leaf, holding its perfect flatness across 60,000 light-years by nothing but the patient balance of its own turning. That flatness is the natural result of rotation, for as the early galaxy spun, it settled into a disk the way a ball of spinning dough flattens into a turning sheet, the spin spreading the matter outward into a thin, broad plane. Nearly every spiral galaxy is flat for this reason, a record of its own turning written in its shape. The disk you see is not a coincidence but a consequence, the inevitable form that gathering spinning matter takes across enough time. Rotation makes the wheel, patiently, out of what began as a shapeless cloud. The stars within that disk all orbit in roughly the same direction, circling the galaxy's centre in a great shared rotation, like a vast slow eddy in which every drop moves the same way around. This shared motion is part of what makes a spiral, what gives it its smooth turning grace rather than the random tumbling of stars in other kinds of galaxy. In Triangulum, as in our own galaxy, the stars move together in a single immense circulation, all turning the same way around the unseen centre, a coordinated dance of 40 billion suns sustained without effort across billions of years. But the motion is not perfectly uniform. The stars bob gently up and down through the plane of the disk as they orbit, rising a little above it and sinking a little below, oscillating slowly through the thin sheet of the galaxy as they circle. The Sun does the same in the Milky Way, drifting up and down through the galactic plane over tens of millions of years, even as it orbits the centre. So the stars of Triangulum are not fixed in a flat sheet, but weave gently through it, each one tracing a slow, undulating path, bobbing through the disk like a swimmer rising and sinking through a current. That slow bobbing, that gentle rise and fall through the plane, is among the calmest motions in the cosmos. A star drifting up through the disk and sinking back over the course of millions of years, in no hurry, following the soft pull of the galaxy's gathered mass. Let the breath find something of that motion, the slow lift of the inhale, the gentle settling of the exhale, rising and falling like a star easing through the plane of its galaxy, unhurried, untroubled, sustained by nothing more than the patient pull of all that surrounds it. At the galaxy's very centre, where there is no great black hole and no swollen bulge, there is instead a modest, dense gathering of stars, a small bright nucleus, crowded but calm, lacking the violence that fierce galactic centres display. The heart of Triangulum is an unusually peaceful place for the core of a great galaxy. No quasar-like glare, no jets of energy, only a denser knot of stars turning quietly at the centre of the wheel. It is a galaxy whose middle is as gentle as its arms, calm all the way to its core. That quiet centre may be the very reason the galaxy has stayed so peaceful. The great black holes at the hearts of other galaxies can, when they feed, blaze with the brilliance of 1,000 galaxies and blast their surroundings with radiation. A galaxy without such a monster is spared all that violence, left to turn and form its stars in peace. Triangulum's lack of a central giant may be part of why it has remained such a gentle, steadily star-forming place across billions of years, undisturbed by the fierce outbursts that rack more troubled galaxies. Sometimes what a thing lacks is exactly what keeps it calm. The galaxy's overall glow, summed across all its stars, is a soft blue-white, the combined light of its many young suns outshining the redder glow of the old. A galaxy still young enough in its star-making that its total colour leans toward the blue. This blue-white shade is the colour of a galaxy in its active prime, still building, still bright with new stars. When astronomers measure that colour, they are reading, in a single number, the vigour of the galaxy's ongoing creation. And Triangulum's blue-white glow says clearly that it is a place still very much alive with the making of suns. If you could pull far enough back to see the whole local group at once, Triangulum would appear as the third bright point in a small constellation of galaxies, the Milky Way and Andromeda the two larger lights, Triangulum the third, and a scatter of dim dwarf galaxies around them like faint sparks. The whole family would hang together in a region of space a few million light-years across, isolated in the dark, bound by gravity, drifting together through the vaster universe. From far enough away, our entire galactic neighbourhood would be a single small cluster of light, and Triangulum one of its 3 brightest members. And that whole bright family, the entire local group, is itself drifting, pulled gently toward a far greater concentration of galaxies, a great gravitational anchor in the distant cosmos toward which our local family slowly falls. Everything is being drawn toward something larger. Nothing in the universe sits truly still. Triangulum drifts toward Andromeda. The local group drifts toward the greater clusters. The clusters stream along the cosmic web, all of it in slow, vast gravitational motion, falling endlessly and gently through the dark toward the deeper gatherings of matter. There is no fear in all that falling, for it is the gentlest falling imaginable. Motion so slow and so smooth that across any human span it cannot even be felt, a drift measured in millions of years. The universe is everywhere in motion and everywhere at peace, the two not in tension but the same. To fall in the cosmos is simply to be carried by gravity, held and guided, never dropped, never lost, drawn along through the dark at a pace so unhurried it reads, from within, as perfect rest. Let that be the shape of your own descent into sleep now. Not a dropping, but a gentle drawing down, carried by something patient and sure, falling slowly the way a galaxy falls, without fear and without effort toward a deeper place. There is a chance, astronomers note, that Triangulum holds a few small companion galaxies of its own, faint dwarf systems orbiting it the way it may orbit Andromeda, dim clusters of stars held in its gravitational sway. The largest galaxies keep retinues of smaller ones, and even a modest spiral like Triangulum may have its own small attendants, faint and hard to see, circling it across the dark. The hierarchy of gravity runs all the way down. Great galaxies hold lesser ones, which may hold lesser ones still, each cradled in the pull of something larger. One faint dwarf galaxy in particular sits near Triangulum in the sky, and astronomers have wondered whether it might be a true companion, bound to the spiral and circling it slowly across millions of years. Whether it truly orbits Triangulum or merely lies near it by chance is not yet certain, another of the gentle, unresolved questions that surround this distant galaxy. But the possibility is a lovely one, that even Triangulum, itself perhaps a companion to Andromeda, might have a small faint companion of its own, a still smaller light held in its quiet keeping. The relationships among galaxies traced out form a kind of family tree of gravity, the great ones holding the lesser perhaps holding lesser still, all of it bound across the dark into a single structure. Triangulum's place in that tree is somewhere in the gentle middle, smaller than the giants, larger than the dwarfs, perhaps a companion above and perhaps with companions below, held in the web of mutual pull that ties the whole local group together. No galaxy stands entirely alone. Each is bound to others, held and holding, across the patient-reaching dark. The gravity that binds them all acts with no delay across those immense distances, reaching instantly and effortlessly through the void, a force that needs no medium, that crosses the emptier space as easily as the fullest, tying Triangulum to Andromeda and the local group to the wider cosmos, with bonds that nothing can sever or block. It is the quietest of the great forces, making no light and no sound, and yet it is the architect of everything, gathering the gas into stars, the stars into galaxies, the galaxies into clusters, building the whole structure of the universe out of nothing but its own gentle, unrelenting pull. It is worth resting for a moment on the gentleness of gravity, for though it builds the grandest things in the cosmos, it does so with the softest of touches, a pull so slight at any instant that it takes millions of years to gather a galaxy, billions to draw two galaxies together. There is nothing sudden or forceful in it. It works by patience alone, by the endless accumulation of the smallest tugs, shaping the universe not through power, but through time. The mightier sculpture of the cosmos is also its most unhurried. Across the disk of Triangulum, the brightness varies from place to place, brighter along the star-forming arms, dimmer in the spaces between, brightest of all in the great nurseries and at the modest central nucleus. This variation in brightness is, in effect, a map of where the action is, the bright regions marking where stars are being born, and the dim regions marking where the galaxy is older and quieter. To read the galaxy's brightness is to read its life story, written in light and shadow across the turning disk, the bright present of the arms, the dim past of the spaces between. The dust lanes, those darker ribbons winding through the disk, are where future stars are gathering even now, the cold material drawing slowly together toward the moment, ages off when it will collapse and ignite. Each dark lane is a promise of a light to come, a reservoir of the raw stuff of suns held in shadow until its time. So the dark parts of the galaxy are not dead but waiting, pregnant with future fire, the shadow and the coming light bound together in the slow turning of the disk. Nothing in the galaxy is finished, even its darkest lanes are merely earlier in a story that always turns eventually toward light. The whole structure turns so slowly that even at the inner regions where the stars move fastest, a single orbit takes many tens of millions of years. Out at the rim, an orbit can take 250 million. The galaxy keeps a clock so slow that the entire span of human history, every civilization, every story ever told, would not amount to a single tick of it. In the time it takes one outer star to circle the galaxy once, worlds form, and oceans rise, and life arises, and ages pass on a planet the star will never know. The galaxy's sense of time is not ours. It is vast beyond comparison and utterly without hurry. That vastness of time is a balm rather than a vertigo, for there is great rest in knowing that the largest things move the slowest, that the wheel you're watching turns on a clock so grand that nothing in your own small day could ever matter to it. The galaxy does not know your deadlines, your worries, the unfinished tasks of the waking hours. It turns and turns on its million-year clock, indifferent and serene, and beside that turning, the urgencies of a single day grow weightless and fall away. The light from Triangulum, faint as it is, has been studied so carefully that astronomers have built detailed maps of its individual regions, charting the brightest stars, the largest nurseries, the streams of gas, the warp at the edges, the modest nucleus at the heart. Across that whole gulf of millions of light years, the galaxy has been mapped almost as a country is mapped, its features named and measured, its structure understood in remarkable detail. It is one of the best-known galaxies beyond our own, a distant land surveyed from afar through nothing but its faint and ancient light. And yet, for all that careful mapping, the galaxy keeps its mysteries, its uncertain past with Andromeda, its possible companions, the precise shape of its dark halo, the full story of its formation. Much is known and much remains open, held in the gentle uncertainty that surrounds all distant things. There is no need to resolve it all. The galaxy is content to be partly known and partly mysterious, and there is a deep rest in letting it remain so, in not needing every question answered, in letting some things stay soft-edged and unresolved in the dark, the way the galaxy's own glow stays soft-edged against the night. Picture the galaxy one more time as a whole, a wide, open spiral of blue and rose and gold, turning slowly against the black, freckled with the pink of newborn stars and threaded with dark lanes of waiting dust, wrapped in an unseen halo of dark matter, drifting gently toward its great neighbour across an ocean of empty space. 40 billion suns turning together in silence 3 million years away, and a single thread of its ancient light arriving now, here, falling soft on a resting eye in a darkened room. It is enough simply to hold that image and let it be, a calm wheel of light, very old and very far, turning without hurry, asking nothing, offering only its faint and ancient glow to whoever happens to be looking. You do not need to understand it, or remember it, or do anything at all with it. You need only let it turn in the mind for a moment, soft and luminous, and then let even that image grow dim, as the eye, in the dark, lets go of the faintest things. The last and quietest wonder is this, that across all the immensity of space and time you have drifted through tonight, the 3 million light years, the 40 billion suns, the billions of years of turning, the ancient hydrogen and the newborn stars and the slow falling of galaxies toward one another, across all of it, there is a single thread that runs unbroken from that distant wheel of light to the body lying here in the dark. You are made of the same ancient elements, forged in stars like the ones you have been watching, scattered and gathered and scattered again across cosmic time. The iron in your blood, the calcium in your bones, the oxygen moving slowly through you now. All of it was made in stars, and all of it is, in the deepest sense, of one substance with that faraway galaxy. So the great glow in the little triangle of stars is not a stranger after all. It is kin, distant, vast, ancient kin, turning in the dark 3 million years away, made of the same star-forged stuff as the hand resting on the blanket and the breath rising and falling in the chest. To look at it is to look at a far reflection of what you yourself are made from, and to rest, here, beneath it, is to rest within the same great calm that holds the galaxy itself, the same patient gravity, the same vast and unhurried time, the same dark sea of unseen matter that cradles every shining thing and lets it lie at ease. There is nothing left to do now. The journey across the galaxy is complete, and you have arrived nowhere in particular, which is exactly where rest lives. If you are still here, still drifting at the edge of sleep, another quiet journey is already waiting for you on the screen, ready whenever you wish it, or never at all. There is no need to choose, no need to move, nothing required of you but to lie still and let the night hold you as the dark holds the stars. You do not need to carry any of it with you. Not the numbers, not the names, not the shape of the spiral or the colour of its arms. Let it all settle out of the mind the way dust settles out of still air, slowly, gently, leaving the mind clear and quiet and empty. Whatever stayed, stayed on its own. Whatever drifted away was never a weight you needed to bear. The galaxy will go on turning whether or not you remember a single thing about it, and that is a kind of freedom. to have looked at something vast and beautiful, and to be asked in return for nothing at all. Let the breath grow slower now and softer. Let the body grow heavy against the bed, sinking a little with each breath out, held and supported, needing to hold nothing up. The room is dark and safe around you. The far galaxy turns, silent and serene, an ocean of dark away, and its faint light asks nothing of you. There is only the breath, slowing, only the body, settling, only the dark, gentle and complete gathering you in. Let the mind go loose now, like a hand opening in sleep. Let the last thoughts dim, the way the faintest star dims when the eye finally closes. There is nowhere to go, and nothing to do, and no one watching but the calm and distant stars. Rest now. The wheel of light turns on without you, and that is well. You have looked long enough into the deep, and the deep has held you kindly, and now 101 wonders are resting with you. Sleep now. Good night.